Hello students, in the previous video I had explained you the geometrical interpretation of two identities, that was a plus b whole square and a minus b whole square. Now let's come to the identity of a square minus b square. What you are going to do for this, you are going to draw a square ABCD. Each side length is of a unit. What you are going to do, you are going to cut off AP equal to B. I'm marking a point here, naming P. It is of the length B. So what will the length of PD? It will be A minus B. Now cut off a point X such that it is of the length B. So you have AXYP, which is a square of length B. Each side is of the length B. Now join CY. What you can say that the area of APXY is B square because it is a square whose each side is of the length B, and area of square ABCD is A square because the length of each side is A. So now to find the identity, to represent geometrically the identity of A square minus B square, what you are going to write, area of square ABCD minus area of square AXYP. What you are going to do, this was the square ABCD, another square in the middle, AX, AP, XY, and we join YC. So area ABCD minus area APXY, both are square. You can write square is equal to, अब अपने पूरे ABCD के एरिया में से APXY का एरिया हटा दिया तो आपको क्या मिलेगा, एरिया ऑफ ट्रेपीजियम XBCY प्लस एरिया ऑफ ट्रेपीजियम PYCD. Now the formula of area of trapezium is half into sum of parallel sides into height. Now let's put the value A square, because the area of square ABCD was A square, area of square APXY is B square, equal to, first trapezium is XBYC. In XBYC, the sum of parallel side is A plus B, because the bottom side is of the length B and the upper side XY is of the length, bottom side BC is of length A and the upper side XY is of the length B. Multiply by height is A minus B. This is the height XB. Similarly, the area of trapezium PYCD is equal to half. PYCD, again the parallel sides are this PY and CD, so the sum will be A plus B, and again the height will be A minus B. Now see, half of something plus half of something makes a complete thing, so you can write A square minus B square is equal to A plus B multiplied by A minus B. This is the geometrical representation of identity A square minus B square is equals to A plus B multiplied by A minus B. Now let's come to the next and the last one, in which you have to do the geometrical representation of the identity X plus A multiply by x plus b. So what you're going to do, you're going to construct a square. Let us draw a rectangle ABCD. Each of length is equal to x plus a and the breadth is equal to x plus b. Mark a point P and M. Now join it, make another point O such that it is a square. Each of side length equal to x. Now draw a dotted line, mark a point F such that it is a rectangle. Now this length is equal to P. If this is x, AP is x, then PD is equal to A. So now area of rectangle ABCD is equal to area of square AMOP plus area of rectangle MBCF plus area of rectangle POFD. How you are going to do this? Area of square ABCD is equal to x plus A, rectangle multiply by x plus b. It is equal to, first of all, the area of square AMOP, which is equal to x square plus the area of rectangle MBCF, which is equal to length is x plus a and the breadth is b plus area of rectangle POFD. The length is a and the breadth is b. The length is a and the breadth is x. I'm solving. You'll get x square plus bx plus ab and plus ax. X can be taken common from these two terms. But you can write x square plus x common multiply by a plus b plus ab. I'm writing on the top x square plus x common multiply by a plus b and plus bx. This is the geometrical representation of identity x plus a multiplied by x plus b. Now how you are going to apply these identities? But before that, we shall study the cases of identity 4. The fourth identity was x plus a multiplied by x plus b. When a is equal to b, then identity becomes x plus a multiplied by x plus a, that is x plus a whole square. Now what you are going to do, you studied the identity x plus a multiplied by x plus b equal to x square plus x common multiplied by a plus b plus ab. So what you are going to put instead of b, you are going to put a. So you will get x square plus 2ax plus a square. अच्छा, ये तो हो गया जब आपने b की जगह a को पुट कर दिया. बस जब आप b की जगह a को पुट करते हो तो x प्लस ए मल्टीप्लाई बाय x प्लस इज एक्चुअली x प्लस ए होल स्क्वायर. तो आप यहाँ पर a प्लस बी के होल स्क्वायर की आइडेंटिटी भी यूज़ कर सकते हो. Now when a is equals to minus c and b equal to minus c, then simply put minus c in place of a and b and solve for the equation. When b equal to minus a, again you have to put b equal to minus a on the left hand side and solve the right hand side identity. Now application of the identity. What we will see that the multiplication of binomial expressions can be made easier by using these identities. So for example, if you have to find out the square of a larger number, say 999 square, it is very tough to multiply 999 multiply by 999 two times. Not that tough, but it will take time. Instead of 999, you can write 1000 minus 1 whole square. Now you can compare it with a minus b whole square. The identity is equal to a square, so 1000 square plus b square यानी कि 1 square minus 2ab यानी कि 2 multiplied by 1000 multiplied by 1. What you'll get? 2000. See, doing the square of 1000 is very simple. You just have to double the number of zeros. Plus 1 minus 2000. You got? You got this. Plus 1 minus 2000. So now on subtracting 2000 from this, you will get and now on adding 1 you will get 998 0 0 1. This was an easier calculation. So using an identity always makes your calculation simpler. Now for example, you have to find the result of 701 multiplied by 699. Doing it directly will take a lot of time. What you can write 701 as 700 plus 1, and what you can write 699 as 700 minus 1. You can compare it with a plus b multiplied by a minus b, and the identity is equal to a square minus b square. So you can write 7000 square minus 1 square. Doing the square of 700, sorry, not 7000. Doing the square of 700 is also easier. It will be equal to 49 and 4 zeros. How 49 and 4 zeros? Because 700, you can write 700 as 7 into 100, and writing 700 two times, you can write 7 into 100 into 7 into 100. Multiplying 7 into 7, you will get 49. I multiply 100, you will get 4 times 0, 10,000. So you can write directly 700 square equal to 4,90,000, and plus minus 1, you will get 480,489,999. Simple. So your identities always make your calculation simpler. Now the second example is about using identity to find the value of x. It is given 8x equal to 93 square minus 83 square. See, 93 square minus 83 square somewhat feels like a square minus b square. So what you can write, 8x equal to 93 plus 83 multiply by 93 minus 83. So now 93 plus 83 multiply by 93 minus 83. What you will get? 176 into 10. It is equal to 8x. X is in multiplication. You will take it as division on the right side. You will get, this will get cancelled out, 22. So you get the value of x as 220. So this is how you use the identity to find the value of x. Now using identities to find the product of two polynomials, here particularly is the case of binomials. Again, 4x plus 5 multiply 4x minus 2, it is somewhat like x plus a multiplied by x minus a. Better say x plus a multiplied by x plus b. On comparing, you will get the x here is 4x, a here is 5, and b here is minus 2. You just have to simply write the complete identity of x plus a multiplied by x plus b, and put the value of x as 4x, the value of a is equal to 5, and the value of b equal to minus 2. Nothing else. Now the proving questions, what you can do, it is given 3x plus 7 square minus 84x equal to 3x minus 7 whole square. So when you are solving left hand side, you will apply the identity of a plus b whole square, then you will solve.